Hello everyone, today we're taking a look at Grasshopper again, and today we have a very special kind of episode which we talk about the introduction of Grasshopper and introduction to Kangaroo. So that's basically a plugin that exists in the Grasshopper environment, and it can give you the very special feats of creating membranes and things that are usable in your design, and can easily make like a natural kind of looking form in your design as well. It's almost like a physics simulator. So the way we're going to tackle this is basically I'm going to show you how Kangaroo handles meshes, and then we're going to get to the certain way of how those meshes are like solved in the solver in Kangaroo, and then we also talk about a little bit about custom preview and the defining of the mesh itself. So as you see here, we have three boxes that have some certain points on them, and they basically get connected and they form a basic shape like this, which is very similar to the one you see in the final one here. However, it's also kind of it is very static, and we wanted to create one which is like more kind of flexible and moves more with the design, so it kind of like turns around a little bit. And we're first gonna create those boxes and the line in between those. Then we're gonna create the mesh itself. Afterwards, we're going to take a look of how Kangaroo handles the meshes, and then we're gonna have this like as a output. So first of all, so we have our geometry. It's just like three boxes that you can just extrude very simply with box like this. Okay, it's over there in this case, and we're gonna import this geometry first in the Grasshopper environment. So just type in geometry, right click, set multiple geometry, click those things, and now you see here it is green, and now it's basically existent in the Grasshopper environment. Next thing we're gonna do is we have to get those points here at the edge or at the edges, and we're gonna have a certain reference point that goes to this point and basically takes the nearest point, so we can create kind of some kind of like polyline. So the way we do it is we just we use the command point, right click, set one point, and it might be in a weird direction here at mine because I have it weirdly set up. So I'm gonna move the points with the gumball move. If you just click on it like this, I'm gonna move the point to a certain direction, so it's like near all the points. And next thing we're gonna do is we're gonna deconstruct the B-wrap of the box with this one here, and this gives us the faces, vertices, and edges, and we just want to have the vertices, and basically we want to compare the vertices that we have, or the points, with the points we had on the boxes here. So we're gonna use the command under, and you look this up, closest point, I think it's called. Yeah, closest points. It's under vector closest points, and as a point cloud we take the vertices, and as a point we want to reference it to take the point here in the middle, and we want to have the count to maybe 2, and then as a result, if we just had everything else about that, we see we have the nearest points to this middle point. And if I move this around, you see it changes depending on that. So it's quite useful to get like the nearest point of that. Next thing we're gonna do is we just connect those points with each other with a polyline, and just slide this in here. And as you see, it just creates a polyline in between those things, but we want to have the polyline connected to each tree, because right now the vertices that are getting as output are actually only in each of the single boxes, so we just want to flatten the tree basically, and then we connect those the in between, basically between those points. And we are just gonna also, because you want to have a closed kind of surface, we want to connect this one as well, so we just right click this here, set the boolean to true, and it actually closes this point. So we already have, and then with patch we can basically already have some kind of surface around that kind of fits together, and it works reasonably well. It is a usable surface. However, it doesn't have this really kind of like angle that we wanted. The other one is kind of like bulging down of just natural forces that you would have like in a membrane structure. So we're going to first, so in the Kangaroo command, which is either installed directly natively in the Grasshopper environment, or you need to download it on foodforrhino.com. It's very easy, it's free, it's a very easy to set up thing to do. You have a lot of components that you can use. So for example, there's certain goals, and there's also like a main component and also a mesh and a utility. So everything that you want to create some kind of physical change in the things that you have in your components, you can use the goal commands. Then you put those all together in the main commands, and the mesh and utility commands are basically for just additional use value. You can actually also use them on other things that are basically incompatible. They're compatible with the other things as well. So we're going to just for now reduce our experimenting on the bouncy solver, which basically iterates through those things and gives you a solution after like a certain number of times of iterating it. And we have to get them, it works solely with meshes, so we have to convert this surface patch to a mesh. And because it's all kind of weird shape, we actually gonna use the just the command mesh, and it creates a certain mesh to it, and we might be happy with it actually, but obviously the edges might be a little bit more difficult to determine correctly. A good way to do it is actually to use the mesh settings and the utilization of the mesh component, and here you can basically modify how this surface gets created into a mesh. So we're gonna just put this in here, and we're gonna hide that, and here we have a certain settings to adjust our mesh that we have. So one that it is a good way to just connect certain sliders to it, so you can kind of see what it does more or less. For example, here obviously like the maximum edge between these meshes gets like reduced, so if you want to have a more detailed mesh, you just reduce it like this. However, it also can increase the processing power, so the computational time to process it, so we might have it as a limited thing. And then you also have some other ones that you might want to use in order to have your mesh in a certain way. So also this one might be interesting. It's just something to play around with, because you want your mesh to be looking like let's say okay, because if a mesh is too dense, it's not usable for the calculation. You want to have a mesh that is like decent enough but not overcomplicated. Okay, this is true. Aspect ratio. Yeah, this is also something, because you might want to change it as well. But yeah, just play around with it a little bit, and then when you're happy with the mesh, then you can use the final one. So I have those settings at the moment, but I would recommend to just, this would looks like an okay mesh at the moment for me. So the next thing we're gonna do is we have to under the Kangaroo command, we have the goals points, we have the load commands. That is quite useful, and then we also have the length command with the strings, the length basically between those things that is determined. And then we also need some kind of anchor point, so the edge of this thing is clearly like determined. So that we have under the anchor commands, which is, should look myself a goals point as well, the anchor one. And so what I would like to do is just yeah, I think it's the best if we just determine, for example, just the outline of that, and maybe actually it would be more useful if we determine only every second edge. So I might need to do some experimenting here, because it is a little bit of a different script than we had before, but well, I think we could get through this for sure. So we are having a certain way to do it. Okay, so we have to first determine like the outline of this. So I think a good way to do it is just to do the mesh edges command, which well, it gives either the outline or the meshes in between that we need for the springs to have some kind of hardness to it. So we need that for the interior edges, and then we need also the line length. It's kind of very cryptic at the moment, but it will make sense the further you go down the road. So we need to determine basically the line length that we want to have in here, and we're gonna basically measure the length of the current lines that we have and make them a bit small, so it's kind of like compressing itself a little bit. So you're gonna do this by this, so it gets multiplied by a certain amount of value and it gets smaller. And then we also will apply a force to each of those points as well. So we're gonna use the deconstruct mesh component, which basically gives us all the outside points, and then we're going to put those in the outer mesh, in the load command, and we want to also attach a certain number value to it that defines this load that is going on those things. And as you see, there was happening something. If you're gonna actually just put a button here as well, and gonna put that here, you're gonna see it's basically moving upside really, really quickly, because we have no anchor point that defines the edge of those boxes. So we're just gonna, it is not applied yet, but we have to define that. So in order to get those edge points, I think we actually have them here, for example. A good way to do is just by joining the curve, and then you have basically the outline curve, and actually explode this curve, and then you get the outside vertices, like the outside points that define this curve, as you see here. So we're going to put this in our points, and the target would be the same points. So we just put this anchor with a shift click in the goal objects, and now we have those things defined. So I think yeah, actually now it actually works. However, you don't see anything moving. It's because it's basically, I think at the moment, all kind of like rigid. Actually, let me see if it's still moving upstairs. So let me actually quickly. So we have those things here. And the anchor points should be defined correctly. Let me actually take a look of how we made it in the other example. I actually don't know if let me see. Yeah, here we also had the outer surface of the thing, and we took the naked edges as the outline, and we put those in there. And I think we also need to define. I think the force vector might be too strong. I think that might be fixing that in a more a better way. Not this one. I'm really sure this. Okay. So I think I'm gonna reduce this first in order for it. You see, it will still moving upwards, and the mesh also doing that. I think maybe actually when we're putting the strings in, this will actually have some kind of value to it. Yeah. Okay. So that's basically, for example, in this case, a typical way of problem solving. You kind of like think, you try to determine the problem, and sometimes you just try something and then it just works. So, however, it's kind of true that it was not determined by anything. It was just basically there was no anchor, there was no like strength to the mesh itself. So we're just gonna hide those things for now. And as you see, we already have the shape that we want to look for. And it has this very nice kind of movement to it in case you want to change the form of it. Okay, so I think that's already kind of good. However, there are two things I still want to do. So basically, first I want the problem I'm having here, it's here in the air, so it's just like as if there would be a wall. Obviously that could be fixable, but I wanted only to be at the edges here as well. So we need to basically put those points that are here and just move this, put those points as the anchor points. And as well, right now you don't really see a mesh, so we need to actually use the show command, which is under main show here, and we have to take the main mesh we have at the beginning, and again shift click it on the goal objects, and now you see an actually kind of 3D shape to it. And I also wanted to have to be only not like the points as well, but like only the mesh itself. So you see, you will have a nice mesh that is like in that direction and usable. Okay, so the next thing we're gonna do is we need to define those points that are only on this curve. I think a good way of doing it is actually we had the main points here, right? And we're just gonna basically redefine the polyline that we have there. And so we have now this like line that we want to have the points on, and those are all the points that we have here. So I think there should be a command under analysis. And I think that would be the best thing to do it. So you have basically under analysis, curve closest point, we can basically define the distance of the points to a curve, and then we would be able to remove the points who are further away than a certain distance. So the points we have are the vertices here, and those are the curves. And now we have a certain distance of each of those points, and you obviously see, I think we'll see here, yeah, sometimes the distance is very, very small. So this is basically, those are like those points are really, really close. Otherwise they're like really, really tall, and we just want to have those like really kind of small 0.00 kind of really close points. So we're gonna use the under math larger than or smaller than, could be, we use both, and we determine the first number, and then we also use the second number, and this should be something like rather low. Let me do this, and it basically gives us a true or false value depending on how fast those are. So basically now every number, how far away those are. So right now every number which is below 041 will be removed from that list. So we're going to use the dispatch usage pattern, and we're going to use the pattern that we have here of trues and false of the list of points that we had here in the segments in the beginning. And we're just gonna hide that, And if we're gonna put the geometry in here now, we see we have exactly those points on the list that we wanted to use. So I think it's pretty useful. Here, for example, see there's a point that is still taken there, and if we just reduce this number, you see this point will get removed. So I'm actually kind of happy that this worked without any complications, and we are going to use those points now as the point targets. Let me actually just reset this. Okay, interesting. Well, as you see here now, let me actually reduce the value of that a little bit. Okay, this is something that I didn't take in mind, for example, in this case. But here the problem is kind of because we have those loose ends kind of not really determined, and they're just like flowing around there. We either have to define the mesh properly, or we need to remove those vertices there, basically. However, I think to keep this this tutorial now simple, I would just use the initial points that we have and just define those for the moment, which I think still has a reasonable outlook of that. So then now when you have those things defined, we are going to also make a preview of it, so it blends in more with the environment of the of Rhino, and we can use the custom preview command for that. And then we want to give it a certain color as well. So if you just put it in here like this, you see it as a rather pink color, and I want to maybe change it to a different one if you have a if you want to have it, like, for example, green, like the color of the Grasshopper, for example. So I'm going to use the RGB command and assign as a material, and then give certain values from 1 to 255. So it has the color that you want to have. You can also just use actually a color picker. Like this is, I think it might make maybe more sense, and it makes it more easy adjustable. And also you can have some kind of transparency to it if you want to have like a little bit of like a see-through effect. So it just color that I like more. Want to have like more of a greenish, like a more defined green. I think it's kind of actually. So yeah, and then the good thing now is, for example, if you have a change of design and you want to move your place somewhere else, it automatically adjusts to the situation. And if you have like a membrane that is more defined by, like, if it goes like more up, it obviously would move up and down. And the cool thing as well that you have, for example, the outlines of the resulting mesh here, for example, and once you, for example, you have the final form, you can have put some kind of like pipe command over it with a like lower radius. And then you have basically your form here, and you can just bake that, for example, in the environment, and then you have like a very nice structure in the end that you can use for all kinds of purposes, that looks a little bit more natural and usable in your design. So yeah, well, I hope you like this way of like designing with a Kangaroo, and I think it has a lot of potential that you can use and further refine the design. Obviously right now it's still kind of, there are a lot of open questions about this and a lot of things that are left unanswered, but I think in the end it is a way of thinking about the design and using it for your advantage. If you want to have a form and like use it quickly and you want to adjust for it in a rather quick way, I think that's the perfect way to do it. So yeah, thank you very much for watching and have a great day.